today that if I were looking at just the side of the equal sign, triangular form means where there's just one thing on the bottom, two things in the middle, and three things on the top. You see how it forms a triangle. Okay? So what we looked at is when it's in triangular form, I can go back and substitute. Because if I know the one thing, I can go back and find the second thing, and then I know the two things, and I can go back and find the third thing. And so today, that's our goal, is to get to triangular form. And the way we're going to do it is something involving elimination. Do you guys remember what elimination was? What did we do for elimination? Yeah, you multiplied and added things together, right? Well, today, we're going to do Gaussian elimination. And Gaussian elimination basically are just kind of some guidelines so you understand what things you can and cannot do in a system. And hopefully they make sense. And the reason it's called Gaussian, like what's that funny name? Gauss is the name of a mathematician. So it's named after that guy, Gauss. That's why it's named that. So here's the deal. Our goal, Gaussian elimination, is going to allow us to get to triangular form. And here are kind of the rules to do that. First of all, at any time, you may interchange any two equations. Of the system. So at any time, if I'm doing things together, I can, as long as it's something that I got by doing these rules, I can take one of the rows out and put a different row in. Like for instance, if I have 3 rows, I can move the third row to the top if I want to. I can interchange rows at any time. So interchange any two equations of the system. The second thing, and hopefully the second and third thing are kind of remind you of elimination. At any time, you may multiply or divide. You can multiply or divide one row or one equation by a number. By any, and as long as it's not 0, I shouldn't have to state that, but what would happen if I multiplied an equation by 0? It would all go away. So you can multiply and divide one equation by any non-zero number to make it simpler or to eliminate. And the third thing is what Connor stated before. At any time you can add rows together. So third, we can add a multiple of one equation to any other equation. Alright, so I kind of use the same, there's always going to be 3 at max. There's 3 steps that will get you to triangular form. Okay? Sometimes if you're good at these and you look ahead, sometimes you might notice you can do some others of these things and skip steps, but always you could get there in 3 steps. And I'm going to write down a system,
that's not in triangular form, and then I'm going to talk you through what basically the 3 steps are, and then we're going to do them. Okay? So let's say I gave you a system to solve, but it wasn't nice, but instead it looked like this. X minus 2y plus z equals 7. Second row, 3x minus 5y plus z equals 14. And third row, 2x minus 2y minus z equals 3. Okay, so now you're thinking, shoot, that isn't quite so easy, is it? But if I know my goal is to get to that, then I'm just going to kind of go about it logically. Here's what we're going to do. In the bottom row of triangular form, what variables are gone? In the bottom row of triangular form, what variables are gone? X and Y. In the middle row, what's gone? X. So here's my 3 steps, Max. I get rid of X here. I get rid of X here. And then I have Y's and Z's, and then I can get rid of Y here. Okay? So get rid of X in row 1, get rid of X in row, get rid of X in row 2, get rid of X in row 3, and then get rid of Y in row 3. Those are our 3 steps. Okay? So here's the deal. I kind of use row 1 as my anchor, and remember how I said if some of you are really good at this, you might notice right away. Does anybody notice right away something that could have been eliminated by not doing what I just talked about? Yeah, well, or Z's. Yeah. So, again, you want to go your own way, blaze a trail of Gaussian elimination, knock yourself out. But this way will always work. So I'm going to get rid of X in row 2. What could you multiply the top row by? I'm just concerned about X. Just want to get rid of X in row 2. What could I multiply the top row by that's going to allow me to get rid of this in row 2? Negative 3. All right, here's what I'm going to do. I'm going to write it up here. We're going to do negative 3 times row 1. And we're going to add it on to row 2. And I'm going to do my little work over here. I noticed, do you see how I put parentheses around the whole thing? Multiply the whole row. Alright, so would you tell me then, what is negative 3 times row 1? Negative 3x plus 6y minus 3z equals negative 21. I am going to write row 2 just below it. Notice I'm kind of doing my work over here, and I'm already leaving my system over here. Would you please add those together? Remember, I'm following the rules. I just multiplied a row by something. I just added it to another row. What do I get? Y minus 2z equals negative 7. since I just added it to row 2, I am going to put it in row 2's place. Remember how I said at any time you can interchange things? So this is going to be my new row 2. So now, let's go over here again. Now my system was x minus 2y plus z equals 7. That did not change. But now my new row 2 is y minus 2z equals negative 7. And I did not do anything with row 3 yet. Alrighty, so remember what my goal was? Get rid of x in row 2, then get rid of x where? In row 3. Once again, I would like you to look at the top and now the bottom row. Can somebody tell me what can I multiply the top row by that's going to let me eliminate the 2x in the bottom row? Negative 2. All right, here we go. So I'm going to write it out. We're going to do negative 2 times row 1. We're going to add it on to row 3. So then I have, multiply that by negative 2. Negative 2x plus 4y minus 2z equals negative 14. It didn't change row 3 at all. 2x minus 2y minus z equals 3. Yes, ma'am. Negative 2x, negative times negative, I did make that positive, and then negative times positive. Alright, let's add them together. So, eliminated x's, that's what I wanted. Now I have 2y minus 3z equals negative 11. Where do you think I'm going to put that? What did I just add it to? Row 3. So because that's what I'm adding it to. Remember, that was my goal to eliminate that. That's where I'm going to put it back in. Alright, so how many steps have we done now? Do you remember how many minimum? Yeah, I said 3. So we have 1 more to do. I have not done anything with the top row. The second row is still the same from step 1, but now this is my new row 3. Okay. At first it might not have made sense. Why do I have to do x first in row 2, then in row 3? I hope it makes sense now. Because now what is it going to allow me to do? Now that I have x gone here and here. It's going to allow me to eliminate y using my bottom 2 equations. Okay, so remember, to get triangular form, we want just a z on the bottom. We want to eliminate this y. Can somebody tell me what I should do then? Good. Negative 2 times row 2. And I'm going to add it on to row 3. By the way, it just so happens in here that I didn't have to multiply them both by something, but just realize sometimes in elimination, like if this was a 3 and a 2, I mean, you might have to do both to eliminate. Alright, let's do it. Let's find z. So we have negative 2y, I'm multiplying this by negative 2, plus 4z equals 14, and 2y minus 3z equals negative 11. Ooh, I don't even have to do any division. What does z equal? 3. Great. Now technically, where would I put this then? What row is this? row 3, and then I have triangular form. Let's save ourselves because we're doing lots of writing here. Do we really need to write it in row 3, or now can we find the other variables? Would you go back now that we know z is 3, and find x and y, please? Okay, so would you double check that you get x is equal to 2, y is equal to -1, and z is equal to 3. So, yeah, so this is Gaussian elimination. It's lengthy. Lots of variables. I mean, if you look at that, that looks like, whoa, what in the world is all that? So, what Gaussian elimination leads us to as far as matrices, because really, why did we do elimination? And then we did matrices, and now we're doing this. What's the connection? Well, there's something using matrices that allows us to simplify this process or condense it. And it's called reduced row echelon form. So I'm going to give you a little bit of like some vocab, not hard vocab, but just how do I make this into a matrix? And this is not what you did last year, because I know you did some stuff with matrices last year. This is what we call an augmented matrix, okay? So can you write that down, augmented matrix?